We are doing convergence of series part 2. We will focus on the ratio test. Now, in my previous video, I did mention that it is advisable to follow steps when checking whether or not a series is convergent or divergent. So, in that video, I did explain step 1. We will do the divergence test. Just recall that when the limit of the sequence was not equal to 0, or the limit does not exist, that the series then is divergent by the divergence test. But very important, when the limit of the sequence is 0, we have no conclusion and hence continue with the steps. My step 2 was the types. We did do the P-series and the alternating series. Now, in this video, we will do the ratio test. Now, let me just mention a very important fact. If we have a series, it is called absolutely convergent if the series of absolute values is convergent. So that is very important. So if I have any series and I can show that the series of absolute values is convergent, then my series will be absolutely convergent. And then on the other hand, a series called conditionally convergent if it's convergent but not absolutely convergent. So this is very important. When a series is absolutely convergent, it will always be convergent. So when a series is absolutely convergent, it's always convergent. So we're going to look now at the ratio test. So what we're going to do is, so whenever we have a series and that series is in the form of either a combination of factorials and n as your power, or we just have maybe factorials combined with anything like n plus 1, we will always use the ratio test. So that is very important, factorials, or if we have n in our powers, we will use the ratio test. Now, what does the ratio test say? We will find the limit as n approaches infinity of an plus 1 divided by an, but very important, we will take the absolute value of that ratio. Now, what does the test say? If we do the limit and we find a number less than 1, our series will be absolutely convergent because of the absolute value signs and therefore convergent. If our limit is a number greater than 1 or we get infinity, our series is divergent. So let's get straight on to an example. So we need to check if this series is convergent or divergent. Now, just make sure here we have a combination of a factorial and a power of n in our ratio. And that's what I've mentioned here. Whenever you have a combination of a factorial n in your exponent, you will use the ratio test. Now, since an is n factorial over n to the n, we know that an plus 1, we will replace n with n plus 1. Hence, an plus 1 will be n plus 1 factorial divided by n plus 1 to the power of n plus 1. So we will get our an plus 1. There is our an plus 1, we divide by an, and therefore, hence I've different times there. So this formula, please just study it well. And do not forget the absolute value signs. That is often a mistake students make. Now in my next step, what I want you to remember, since we use factorials a lot in the ratio test, please just remember from first year, n plus 1 factorial is n plus 1 times n minus 1, and so on. Hence, n plus 1 factorial is n plus 1 times n factorial. That's what I've done there. Then, very important, I have n plus 1 to the power of n plus 1. Now, from your exponential laws in school, you know you can split them. So you have n plus 1 to the n times n plus 1. And that's what I have done over there. Now, in my next step, I'm going to cancel. These n factorials will cancel. My n plus 1 will cancel. And I'm left with n to the n over n plus 1 to the n, which is n over n plus 1 to the power of n. Now I want you for the exams to really study these. They do come up a lot. The limit as n approaches infinity of n over n plus 1 to the n is 1 over e. And then the opposite. So when we have n plus 1 over n to the n, which I've just simplified here as 1 plus 1 over n, my limit will be e. Now you will recall from my videos on L'Hopital that you actually get the indeterminate form here, since you get 1 to the infinity, and I did do that in the videos on L'Hopital. Then we'll end off getting e. So that's where it comes from. So since I had this, I know now that my answer is 1 over e. And 1 over e is less than 1. Let's just recap. What did I say earlier? When you get a number less than 1, you will say that your series is therefore absolutely convergent and therefore convergent. So since we have a number less than 1, I will just end up saying, therefore my series is absolutely convergent and hence convergent from the ratio test. So please, it's very important that you do end off with that sentence. And it's also important that you mention that you have done it by the ratio test. Very important. Let's do the next question. We are going to check whether or not this series is convergent or divergent. Now, what did I say earlier? Since I have n in my exponent, I am going to do the ratio test. So just another point I want to make clear here. If you have a factorial, it is advisable to skip the divergence test. So that's another of our exceptions when we do not start off with a divergence test. Since there is a factorial in our series, we can skip the first two steps, the divergence test and the types, and go straight on to the ratio test. The same here, since we have n in our exponent and we have a complex number to the power of n, you can always start straight away with a ratio test. Now, what I always advise students to do, you are immediately, you use the ratio test, so you immediately write down the formula. Always do that in maths. Why? Because now from the formula you can see what you need to get. So obviously we need to get n plus 1 first. We're just going to replace n by n plus 1, and there we have a to the n. Now I'm going to use my formula. So just from school, you know if you have a ratio to the power of n, you will say a to the n divided by b to the n, and hence what I've done here, I've done my numerator to the power of n plus 1, my denominator to the n plus 1. Here I did the same, and just recall what I've just said. If you divide by an is a fraction, you will tip and times. Now let's simplify this. So if we have 4 plus 5i to the n plus 1 divided by 4 plus 5i to the n, another of our school formula. So if I have a to the n plus 1 over a to the n, since the bases are the same, I will subtract the exponents. That's very important. You should be familiar with that. Hence, I just end off with 4 plus 5i. The same here, the bases are the same. So I can see here that I'm left with 6 at the bottom. Now, very important, I can take my constant outside. Limit n approaches infinity. Now, the common mistake students make here, so please familiarize yourself with this. This is the magnitude of 4 plus 5i, which is a complex number. Now, very important to remember the magnitude of a complex number. We will do real part squared plus imaginary squared. Common mistake students will take the I with, then say a squared minus b squared. No, it's just your real part squared plus your imaginary squared. So what did I do in this question? I did in my next step, I will have the square root of 4 squared plus 25 squared times 1 over 6, since that term is independent of n. So I will get square root 41 over 6. Now, very important, some students find it hard to see whether or not this term is greater than 1. So what do? You know 41 is between 36 and 49. Why did I use these two numbers? Because 36 is the first number smaller than 41 with a square root, which is 6. 49 is the first number bigger than 41 with a square root, which is 7. So you know square root 41 will be bigger than 6. So if square root 41 is bigger than 6, you will get a fraction greater than 1, since you're getting an improper fraction. So since my value is greater than 1, let's just recap from the theory. Greater than 1, my series will be divergent. So hence my series is divergence, and please remember to mention by the divergence test. Now my next question, what is very popular question in the exams. Find the radius and interval of convergence of this series. Now, what do you see is different from my previous questions? My previous questions will just be the series in N. So you only had values in. Now you can see here that there's a Z. So what do they want us to get? What they're actually asking here, what are the values of Z? Or what can Z take on? Which values? Such that this series is convergent. So we will always, for radius and interval of convergence, do the ratio test. So please remember that whenever you come across a question like that in test or exam, radius and interval of convergence, you will immediately use the ratio test. What does the ratio test do? We're doing the limit as n approaches infinity of the absolute value of an plus 1 divided by an. So let's do our an plus 1. We will replace all our n's with n plus 1. And then there's our an. Now what am I going to do? Because I divide by a fraction, I tip and times. And I hope you're all familiar with the term tip and times from school. Now we have the same situation here as before. We are going to have n plus 1 factorial over n factorial. So I just explained it here again. So you have n plus 1 factorial, which is n plus 1 times n minus 1, and so on. At the bottom you have n factorial. If you cancel, you get n plus 1. And therefore, my n plus 1. Now, what I also did here, I did n plus 1 to the power of n plus 1 will be n plus 1 to the n and n plus 1 to the power of 1. So let's just recap there. I have split it into n plus 1 to the n and n plus 1. But then I have my n to the n and n plus 1 to the n, and hence this step. So those are all basics that you must just make sure you are 100% familiar with. Now what am I going to do? Well, like I said, I did for my factorials, n plus 1 factorial over n factorial, I did get n plus 1. Here I have an n plus 1 left, and I have that term. But most important, don't forget, z to the n plus 1 divided by z to the n is z. And since it is independent of n, I can separate my fraction, and I can even put that absolute value z on the outside. Now just recall what I have just said. The limit of n approaches infinity of n over n plus 1 to the n. Again, this formula, very, very important. So make sure you please study it for the exams. So that is 1 over e. I have my z. What I said earlier, you can take it to the front since it's independent of n. Now we're going to do a very important thing. Remember they said find the radius and interval of convergence of this series. In other words, they're telling us that the series is convergent. Now, what did you learn from the ratio test? If a series is convergent, you will get a value less than 1. So that's why I can always use less than 1 when I find the radius and interval of convergence. And just remember to put your absolute values. But now, since I know that is equal to 1 over e, and I have my z less than 1, I times by e on both sides. So what do I know? Which values can my z take on to be a convergent series? That means that I will have my z equals e, which is a circle center 0, 0, radius e. So for all those values, but just remember we're in the complex plane. So we have our imaginary axis and our real axis, our center 0, 0, our radius e. So anything in that circle will make my series convergent. So that is the end of the ratio test. So make sure you study all the things that I did mention that do come up a lot in exams, and then just make sure that you understand your steps. First step, divergence test. Second step, you look at your types, P series or alternating series. In this video, we did ratio test. Now, in the next video, we will do the integral test.